Imagine a volcano so massive that it would cover the entire state of Arizona, so tall that its summit would be 3 times higher than Mount Everest, so wide that its base stretches 600 kilometers across the Martian landscape. This is Olympus Mons, the largest volcano in the solar system. A shield volcano of such immense scale that it defies terrestrial comparison. Located in the Tharsis region of Mars, this giant has been extinct for millions of years. But its features tell a story of volcanic activity that shaped the red planet and holds clues to Mars's watery past. This is the story of Olympus Mons, the giant that towers over Mars. Why does it matter to planetary scientists? Because it represents a volcanic end member, the extreme of what shield volcanoes can become. Its low gravity, stable crust, and long-term hotspot activity allowed it to grow to impossible proportions. But beyond its size, Olympus Mons holds mysteries: the steep cliffs at its base and the surrounding aureole deposits, and the possible role of water in shaping its unique features. Understanding Olympus Mons helps us understand Mars itself. NASA states, with a base that sprawls across 373 miles, the shield volcano rises to a height of 17 miles. In this documentary, we'll explore every facet of Olympus Mons, from its staggering dimensions to its volcanic origins. This is the complete story of the solar system's largest volcano. Let's begin our journey. Let's start with the most staggering number: height. Olympus Mons stands 27 kilometers above the surrounding Martian plains. To put that in perspective, Mount Everest is just 8.8 kilometers above sea level. You could stack 3 Mount Everests on top of each other and still not reach the summit of Olympus Mons. Its peak rises so high that it actually extends above most of Mars's thin atmosphere. But height is only part of the story. Olympus Mons spans 600 kilometers in diameter, roughly the size of the state of Arizona. Its base is so vast that if you stood at the edge, you couldn't see the summit. It would be hidden below the curvature of the planet. The entire Hawaiian island chain, from the Big Island to Kauai, would fit comfortably within its footprint. The volume is almost incomprehensible. Olympus Mons contains about 100 times more material than Mauna Loa, Earth's largest volcano. Its sheer mass has actually depressed the Martian crust beneath it. The volcano is so heavy that it has created a flexural trough surrounding the entire edifice. Unlike the steep cones of stratovolcanoes, Olympus Mons is a shield volcano with remarkably gentle slopes. The central part rises at an angle of only 1 to 5 degrees, so gradual you could walk up without noticing the incline. But at the edges, everything changes. The periphery terminates in steep cliffs that slope 12 to 28 degrees, dropping 8 kilometers to the plains below. Olympus Mons is a shield volcano formed by the eruption of low-viscosity basaltic lava. Unlike thick, sticky lava that builds steep cones, this fluid lava spreads out in thin layers, creating a broad, gently sloping profile. Over millions of years, layer upon layer stacked up to create the massive edifice we see today. Eruption rates were similar to those observed in terrestrial hotspot volcanism. Olympus Mons likely formed over a long-lived hotspot, a plume of hot material rising from deep within Mars's mantle. Unlike Earth's moving plates, Mars's thick, immobile crust allowed the volcano to remain stationary. This is why it grew so large. It never moved away from its magma source, feeding from the same hotspot for billions of years. Mars' gravity is only 38% of Earth's. This lower gravity means that lava can build higher structures without collapsing under their own weight. On Mars, the reduced gravity allowed Olympus Mons to reach heights that would be impossible on our planet. Gravity simply doesn't pull it down as strongly. Building something this massive takes time. Geological evidence suggests that the main construction phase lasted approximately 1.1 billion years, from about 3.67 to 2.54 billion years ago. During this period, lava erupted at a rate comparable to Earth's hotspot volcanism. Activity later dropped off, though low-level eruptions may have continued for hundreds of millions of years. A stationary hotspot, low gravity, and over 1 billion years of steady eruptions. This is how Mars built the solar system's greatest giant.